Hello, it's Keith from Kinvert, and in this video I'm going to be learning how to do some tinygrad. So I've done some other things you guys may have seen before, where I've used different ways to do MNIST and different classification things and others as well. And now I want to learn some tinygrad. So that's what I'm doing here. I'm just taking their tutorial at the moment, and I've just checked in this works. It's finding CUDA, and so I'm just gonna see how it goes. This isn't gonna be too in depth, but you can see I just literally went here, so you'll be able to go here in the GitHub, find this link, and follow this. You may want there was a left pane, but I made this smaller. But there's navigation on the left that shows you how to do the installation. It went pretty smooth for me to get this working here in Jupyter Notebook. I had to do some ipykernel installs to get the tinygrad working, but you can find how to do that online, and if anybody has trouble, I might be able to. So let's see. So it looks like a time thing. Oh, that's the accuracy. So, okay. So it's around 10%. So it's just guessing. We haven't trained yet. So this is how we set up the training. I guess it just already import time it. I don't know if it's going to throw all that in there. I guess it will, so we can have the comparison. So it's taken a bit. Okay, so 3 seconds. I wonder if it's running some sort of optimizations, like figuring out what my hardware is the first time. Okay, so yeah, it sped up a lot that time. So the first one took 3 seconds. I really don't know much about how this works yet, but this is part of the learning process here. So it is potentially finding CUDA. Let me check my NVIDIA SMI here, and let's see, tinygrad global reset, and then with debug step. Okay, so this is what's printing all this out, and it's just still doing the same step. Now this might be doing one step instead of a full set, so we can do this, although that probably didn't matter, and then this. So it's taking, all right, so now I'm going to watch my NVIDIA SMI. So I'm at 14%, and it jumped to 25. So yeah, this is using my GPU. I've got a 3070 Ti. All right. I don't know if that's saying it's slow. Gigs per second. Different shapes. I don't yet know what all this is. I've seen a couple of his streams, and I think this has to do with shapes, and but I really don't. So 32 and 10. So 10, this could just be the output size. But anyway, this is stuff I'll learn later. JIT step. So I wonder if that's going to speed it up, because it's just kind of taking step from before, I assume, and applying this, put it in this class. So the first one was slow. Oh wait, these are e to the, oh, okay. So the first one, okay, it's quicker than this one. And then these are e to the -5. Where these, yeah, we've got just 1 0 here. Okay, yeah, this is orders of magnitude faster with JIT. So we'll have to remember that. And then putting it together, since we're just randomly sampling from the data set, there's no real concept. Kira's example is taking about 7,000 steps. So it doesn't say how long it took, so we'll see. How long have I been recording? 5 minutes. Oh, this is quick. Okay. So it's already pretty accurate, but part of that is I've already trained this multiple times. Oh, so this is going to go to 7,000. All right, so the big thing, this link can get you here. I assume there's navigation up here. Quick start. Oh, it's using some GPU here. Okay, yeah, I'm using my memory now. So my computer might be a little slow. It's actually chunking along. Oh, let's leave this so you can see how fast it's going. Okay, tensors. Okay, so this I'll read later. I just wanted to make sure I've got everything working. Okay, it looks done. That's basically 99% right there. That's not bad. So yeah, you've seen in some of my other videos where I've done some visualizations and stuff. So what did I have it in here? And then the visualizations. Is this where I did it? It was so long ago. But I'm going to be diving into this in more depth. How am I? Okay, so I got like maybe 4 more minutes. Genetic, basic, autoencoders maybe? Here we go. Yeah, so this sort of stuff. I've done this sort of stuff, and I'd like to keep doing this, but trying some of this with tinygrad. So MNIST visualizations. So I don't know if I would change the folder structure a bit. Oh, I could just do a O3 and start doing some tinygrad here, I guess. But yeah, so I'm gonna dig into this more. I've got something coming up where I can do some more fun work, and I'm looking to do it in something other than just Torch or TensorFlow. And I've seen him working on this over time. I've seen some of his streams, so I figured I'd try it out. It is looking promising, and we'll see after I try it out a little bit how it's feeling and how quick it is, and maybe set up some benchmarks. I don't know how to set up like perfectly scientific ones, but it'll still be fun to get the comparisons, and hopefully I can start to fill this in with a little bit more stuff that people can copy and try and get started in machine learning. So anyway, this was Keith from Kinvert, and I went over tinygrad, the very basics, through their tutorial. This is not my code. This is their thing, and I just wanted to see if it worked, and it did basically right out the bat. And with this tinyjit that I'll have to look into, it's actually quite fast. So where did it go? Right here. This is what I need to look into, is how they're doing this, and how I could make use of this and beat the other things I've been doing just with standard TensorFlow and Keras, and I've done a little in C++ and stuff in here as well. So I guess that'll do it, and I will see you guys next time. Bye-bye.